Hello everyone. So let's start the second part of this programming paradigm style. In this part we will see the difference between object oriented versus procedural oriented programming languages. Next one we will see the features of OOP. So in this one let us see the difference. Object oriented programming is the problem solving approach and used where computation is done by using objects. Means basically this programming style focuses on objects. Without objects you can't do any single activity. In the procedural programming, it uses a list of instructions to do computation step by step. That in the previous we have solved some examples in the Python also. We have solved some assignments. In that one, we have simply used step by step instructions to solve a particular program. Such type of way of solving a program of solving a problem is simply a procedural, isn't it? Means it will give we are giving some list of instructions, we are writing some list of instructions to do the computation step by step. The second difference, it makes the development and maintenance easier. Development means code development. When you are going to develop a large software, in that one it is very difficult to write down step by step instructions. So what particular programming style is adopted in that way or in that situation, it is nothing but OOP, object oriented programming. And to maintain the code in OOP is also very easier. In procedural programming, the scenario is exactly somewhat difficult. It is not easy to maintain the code when the program or when the project becomes lengthy. Okay, and hence to develop software applications, object oriented programming style is used in many areas. The third difference is that it simulates the real world entity. So what is the real world entity is present in the OOP? It is nothing but object itself. Object is the real world entity. We will come across what is the exact real world entity concept. And by default in procedural programming there does not exist any real world entity. Means as objects are absent, there will not be any real world entity, but it works on step by step instruction which are given by user, and those are divided into small parts called as a functions. Next, it provides you the feature called as a data hiding. So it is more secure than procedural languages. Means the feature is called as a private data members and public data members. So private data members are the data members which cannot be accessed by different classes. Okay, so if class A is organizing its data into private and public, then private members of class A will not be accessed by class B or class C, but the public members of class A can be accessed by class B and class C. So that is the very good feature of OOP, data hiding. But procedural programming doesn't provide any proper way of data hiding, so it is less secure. So which are the examples of object oriented programming languages? C++, Java, .NET, Python and C Sharp. And procedural languages are C, Fortran, Pascal, VB, etc. The next slide is nothing but features of OOP. So which are the features? Class, object, inheritance, polymorphism, abstraction, encapsulation, method and message passing, containership, reusability and delegation. Let us see one by one. The first one is nothing but class. So what is a class? Class is nothing but a logical entity which doesn't present physically but it presents logically. All computer programs are present in logical way. Means the coding is present, the coding style is logical, but the program is developed, that is a physical entity. But the coding way is nothing but a logical entity. The coding style is nothing but logical entity. So simply class is also coding style and hence it is nothing but a logical entity. It is a blueprint or template of a particular logical entity. Okay, so what do you mean by blueprint or template? So what are you going to do in that particular program? It's simply given by that class. Means how many functions can be used by you in that particular program, which data members means data variables you are going to use. It's simply design or it's simply defined in the class, and that structure is called as a blueprint or template of that particular program, and hence class is called as a template blueprint, or a logical entity. The next feature is nothing but object. So what is the object? Object is a real world entity. So why it is called as a real world entity? Because you can access the data members of a class by using that particular medium, and that medium is nothing but object. It actually operates the data members and functions of a class. Without object you cannot operate any single data member and any single function of a class, and hence it is called as a real world entity. You actually really implement, or you actually really do the operations on that class, and hence object is called as a real world entity. It is also called as an instance of a class. Okay, so instance is also called as a object. Object is also called as a instance. Next one is nothing but inheritance. So as the name itself indicates, inheritance is nothing but to inherit the properties of another one. So simply, if you are going to design three classes in your program, then you can implement inheritance. Okay, so for example, class A, B and C, these three classes are present. All these three classes will have their own functions, but display is the function, and to take input data, these are the two functions. Okay, take input, this will be the first function, and display will be the second function. What is going to be done by these two functions? Input data will take a input from user, and display will display the data of that particular class. Means both functions are doing input a data, display the data, isn't it? So I can use these two functions in three classes. Okay, means class A will take data, it will operate some it will do some operations on that data and it will display. Similarly, class B will take data, it will operate on that data, display the data. C will also do the same, take a data from user, operate on that data and display the data. Means basic task is same for all these classes, for all these functions. Means take a data, display the data. Okay, so that one, this input data and display will be put in a public part, and operations of individual classes will be put in a private part. Okay, and hence I can use input and display function of class A into class B, as well as I can use it into the C class also. So I have inherited input and display function of class A into class B as well as into class C. Okay, so this is nothing but simply a inheritance. Means class B will have its own data, along with it will have the data from class A. Similarly, class C will have its own data along with the data which is inherited from class A. So such type of feature is called as a inheritance. Okay, and this is a feature of object oriented programming. Okay, next one is polymorphism. So polymorphism is nothing but, polymorphism is shown by method, it's shown by functions. So functions are called as a method in OOP. So same method can do multiple actions. Means same method with many forms are called as a polymorphism. Poly, multiple, morphs means forms. Multiple forms will be there, many forms will be there. For example, to wash is a method, isn't it? So you can wash utensils, you can wash clothes, you can wash cars. Means a wash is the method which is doing multiple activities, to washing a cloth, to washing a utensil, or to wash a car itself, isn't it? So such examples or such method is doing multiple actions, it is implemented with multiple forms, it is called as a polymorphism. And this is the, you can do such polymorphism, you can implement such multiple forms methods in this OOP, which is not possible in procedural programming. Next one is abstraction. As I told you, there are two ways of data hiding, sorry, there are two ways of declaring members of a function is there, member of a class is there, public data members and private data members. Okay, so private data members are private data members will hide a particular thing, but public members will show only essential part. Okay, so that particular way is also called as a abstraction, means showing only essential details and hiding background details. Okay, so public data members will show, yes, this task is important, this is essential, but private data members will hide what exactly, in which way that task is done. That is nothing but private data members. That is simply called as a hide background details. Next one is called as encapsulation. So what do you mean by encapsulation? So data and functions are present in a single entity. Packing of data and function into a single unit is called as a data encapsulation. So which is the example of data encapsulation? The best example is class. So we have seen the class. In the class we have seen some variable, and in the class we have seen the member function, isn't it? So data and member functions are present in that entity, single unit, and it is called as a class itself. Next one, methods and message passing, means objects can communicate with each other via message passing, which is not possible in procedural programming. Okay, next one is containership, means what do you mean by containership? Means if two classes are present, both classes can contain data members of each other. Okay, so class A contains other class objects as a data member. Exactly, meaning is that suppose class A is having O1 and O2 objects, class B is having O3 and O4 objects. So O1 and O2 can be accessed by B also, and O3 and O4 can accessed by A also. So this feature is called as a containership, means O1 and O2 can access the data of B, O3 and O4 can access the data of A. So it is called as a containership. Reusability,